All right, so we will go ahead and get started. Hello and welcome to Managing Releases and Contributions at Scale with Mr. Belvedere. I'm Jason Lance. I'm the lead member of technical staff release engineering at Salesforce.org. I've been there for about 3 years, and my job is basically to build our continuous integration and release management processes and the tools to do that. And all of those tools we've actually released as open source. One of those is Cumulus CI, and kind of the other web app piece of that is Mr. Belvedere that we're going to talk about today. Yes, you've all seen this before. Don't make your investment decisions based on anything that I say today. None of this is even Salesforce products. These are just open source products. All right. So quickly, a little bit about Salesforce.org. We used to be called Salesforce Foundation, and we are the corporate philanthropy kind of wing of Salesforce that is built around the 1-1-1 model of corporate philanthropy, which states that companies should give back 1% of their technology, 1% of their people, and 1% of their resources to the community. I work on our products team, and we focus on the 1% technology. We actually give any 501c3 nonprofit 10 free licenses of Enterprise Edition Salesforce, and also offer that to higher education organizations, and then give substantial discounts on top of that. What that means is that we've actually grown to supporting over 29,000 nonprofits and higher education organizations that are running on Salesforce. So on the products team, we build two main products to support those users. The first is, I'm just going to go to the arrow here. The first is the NPSP, or the Nonprofit Success Pack, and the second is the Higher Education Data Architecture, or HEDA. A little bit of background about those products that's relevant for kind of the demo today. The Nonprofit Starter Pack, or Success Pack, actually started as the Nonprofit Starter Pack. It was a community-driven project that we kind of adopted, and it started 9 years ago. There's over 20,000 installations. It is open source, built out on the public GitHub, so the metadata of our managed package repository is actually developed out in a public GitHub repository. And it has a pretty complex dependency map in order to actually do an installation. There's 6 managed packages, and there's also some unpackaged metadata that you have to be able to deploy with those packages. So it's kind of a big burden for a user. So HEDA was launched more recently. It launched in February of this year. It's already grown to over 1,000 installations. It's also open source, built on the public GitHub, and it has a little bit easier dependency map. It's only one managed package, but there's still some unmanaged metadata, specifically some account record types that we didn't want to put into our managed package that need to be installed in order to be able to install the package. So with getting those applications out to all of these users, we faced 4 kind of main challenges that led to the creation of Mr. Belvedere. The first was allowing low-budget, non-technical organizations to install and upgrade our products. A lot of the nonprofits that use Salesforce through Salesforce.org pay us nothing. And a lot of them don't have any tech person in-house. They don't have any IT staff in-house. So we want to make it as easy and seamless as possible for them to install our products. The second is supporting a really agile and aggressive release cadence. Our team on the products team operates on 2-week sprints. We cut production releases of our managed packages at the end of every 2 weeks, and we push those to over 20,000 Salesforceorgs. We also, throughout the development process, as we merge a feature branch in, we cut beta releases through our build process, and we publish those out to our community so they can install new features before they actually make it into a release, mostly in a sandbox org. Then also, we're an open source managed package, which creates this kind of interesting challenge for us, because we invested a lot in having build scripts that were easy for our in-house developers to kind of work with. But when it came to contributors in the community, either declarative admins that really know how to do very creative stuff with the application, or even experienced Apex developers, getting them trained up on how to use our build scripts was kind of a big barrier to getting contributions. And finally, we faced a challenge of supporting installation failures at scale. We average about 25 installations of our products through Mr. Belvedere every day, and we have a pretty small team to support if installation failures happen. What we found was common problems that we know a workaround to. We're getting asked both as a support ticket and in our Salesforce community, user community, the Power of Us hub. And we wanted to be able to kind of present the workaround resolution text to the users a little bit earlier on. So that led to the creation of Mr. Belvedere, which started about 2.5 years ago. Mr. Belvedere is a Python web app built using the Django web framework. We run it on Heroku. It's very easy to deploy now. There's a deploy to Heroku button out on the repository. You can launch your own instance. It runs with a web dyno, a worker dyno, and the Redis message queue for passing jobs to the background worker. And the main functionality of Mr. Belvedere is to be able to be a web-based, user-initiated installer of a map of metadata dependencies in a certain order. Now, when I say metadata dependencies, what I mean is 3 different types. The first is a managed package version. So you know the namespace and a version number of a managed package you want to install. The second is zipped metadata that you've got hosted at a URL somewhere. So you just have a zip file that has a package XML and metadata inside of it. And finally, which we're going to look at in the demo today, is metadata from a GitHub repository. So you can actually serve up any branch from a GitHub repository and make that available for installation. It also provides tracking and support of those installations. So you can monitor what's going on with your installations. You can give next steps to your users to kind of guide them on where to go next after they install. You can also give them contextual help on errors. So we try to genericize error messages, and then admins can go in, and if there's a common error message that we see appearing in installations, we can give resolution content, which is shown to the user right there on the spot. And then finally is the contributor tool that links up GitHub and Salesforce DE org for a contributor to your package. So they make the changes in the org, come back to the tool, do a commit, and submit the contribution to you. So a little bit about the data model of Mr. Belvedere. The core of everything is a package, and that's kind of your main container for your project. And then you have package versions that are related to a package. And those are tied together in a dependency tree map with a package version dependency that says this version requires this other version and has an order field on it as well. And then when an installation runs, you get a package installation object created. And each step in that installation, each step from the dependency map is a package installation step that's linked back to the version that it was installing. And finally, installation errors are tracked as their own object. We actually take the error message and make it more generic. We obscure OIDs and things like that so that we can match common installation failures. So every failing package installation step gets matched to an installation error, and then admins can go in and add content to that error. And we're going to look at how to go through and configure all of that here. So let's jump into the demo. Really quickly, just a little bit of setup that I did beforehand. I created a connected app in a Salesforceorg. The README out in the repository tells you about how to do this. I also deployed Mr. Belvedere using the deploy to Heroku button and created an admin user, which is laid out in the README. So I also created this demo project repository. And in this repository, our main kind of package source is stored under the source directory. Our managed package dependencies are stored in the version.properties file. And then our unmanaged metadata that we want to deploy before and after our source directory is stored in this unpackaged subfolder. So let's jump over real quick and just take a look at what that looks like in the repo. So here's the repository. Like I said, we've got the source directory here. It's got a package XML and a bunch of metadata. We have the version.properties file. And the key lines here is this part here, which says, I want to install a managed package with a namespace pub. And then this line down here defines that I want to install it at version 1.5. So this builds the dependency. It says, in order to deploy this, I have to have the pub managed package installed at version 1.5. And then the other part of dependencies comes from the unpackaged subfolder. And there's 2 subfolders it looks for, pre and post. And so pre is just a small little bundle of metadata. You can see here it's just adding record types on account. And we want to make sure that this runs before we deploy the source directory. So the first thing that we have to do is go tell our new Mr. Belvedere instance how to, or point it at this GitHub repository. So to do that, we've got to create a package version, link that package version out to the source directory of our GitHub repository, and then go set that as the current GitHub version on the package so that it's kind of published and available in the installer. So let's jump over. And this is what you'll see on the homepage of the application when you first launch. It just says there's no packages available and admin needs to go log in. You go to /admin, and log in with the admin username that you create per the README. And I'm going to come down, and I've got to create a new package here. So I'm going to give a namespace to the package, and the namespace is what's used in the URL path. So each installer gets its own endpoint, and that's what's used there. There we go. Now, I also want to give a little bit of content for this version. So I can give some intro content that's going to be shown on the main landing page for the installer, and then content for success. And this is, rich text, and it actually will transform this into SLDS headings for you, and also into SLDS numbered lists, so you can do, here's next steps for you. And, if there's a failure, we can tell them, don't panic, go to, somewhere, our user community or whatever. And so that's basically just giving the general content that we want to display in the installer for that particular package. Now, the next thing that we need to do is build a version for that content, or for that package. So we're going to select the package here. We're going to give it a name of demo, and then we're going to use the metadata from GitHub section. And we've got to give it some info here. We've got to tell it the path to our GitHub repository. I'm going to give it a GitHub user and a GitHub application token as a password, and then tell it that I want to deploy the master branch by default. I want to deploy the source directory, and I want to give it a project name, which is used for the contributor tool. And that's it. Go ahead and save that, and come back to packages. Now what I have to do is go back to the package and create this version as the current GitHub version. So this is kind of the publishing step of the individual versions. Now once I do that, I can go back to the main page of the site, and now I get a listing of here's all the different installers that are available. Here's the production version, the beta version, which you can see are not available, but the GitHub version is available. So I'll go ahead and do this. And the first thing that it's going to do is have me connect to a Salesforceorg. So I'm going to click to log in to an org. Got this DE org that I created. It's just a clean DE org. It's going to prompt me to grant access to the installer. This is using OAuth. And once it does that, it's going to go through and use that OAuth access to query the Salesforce API and find out some information about the org, like what packages are installed, who's the user that's doing the installation. And then it's showing me a customized install map of what steps it's going to run against my org. So if I want to kick off these steps, I just hit the install button. And what this is doing on the Heroku side is the front-end web dyno has basically dropped a message into the Redis message queue. Worker dynos pick up that message and go through and run it. So you can see here it's just doing a metadata API deployment. And this is in particular using the installed package metadata type, which I don't know if everybody's familiar with. It's a really cool kind of special metadata type. You deploy it, and it gets the namespace from the file name, and then it gets the version number from an XML element inside the file. And when you deploy that into an org, it'll install that managed package into the org. So you can install managed packages through the metadata API. You can also uninstall them in the same way. So cool. The installation completed. It just went through and deployed a managed package and 3 sets of unmanaged metadata into my org. And I get my next steps status here. And let me jump back because I realized I just went through that, so we'll skip that one. Now, the next demo that I want to show is how we add resolution text for if there's an error that occurs during the installation. So in order to do that, we need to first create an installation error. And to do that, we're going to use a feature of the GitHub portion of the installer that allows us to point it out at a different Git ref. So we can point it at any commit or any feature branch in the repository and have it install that. And we're going to point it at a branch that has known bad code. Then we're going to see the generic error message that we configured for the package earlier because there's no specific message yet. And then we're going to see how an admin would go in and create the resolution content for that. And then see how that resolution content would get merged into the install page. And then finally, we'll end with looking at the installation or the data that's created from the installation to kind of see how you can track that. So I'm going to go back to my installer. And you'll notice it's re-examining my org now, and the reason why is because it knows that it just ran a deployment against my org, so the metadata might have changed. So it kind of resyncs and makes sure that it's inspecting the org currently. And so now I'm going to point this at a known failing feature branch. And you can see over on the right, it's telling me, yeah, it's now going to deploy this feature branch here. And if I run the installation, yeah, and this is actually a bug that just popped up as as I was getting ready for the Dreamforce presentation, as always happens. It's, for some reason, not seeing the correct version that's installed in the org. So what it's doing now is actually uninstalling the version that was there before. It thinks 6.0 was installed, and it thinks it should have 1.5. So it automatically detects, oh, if you have 6.0 now and you need to go to 1.5, I have to uninstall 6.0 first. So it runs that as the first step to uninstall it, and then it goes back and runs the installation. And of course, here I'm at the mercy of how fast things run through metadata API deployments. All right, so I'm going to actually jump over and show you in my local instance while that's running. And I don't have it configured there. Oh, yeah, here we go. So when you're an administrator, you can go to this /errors view on any installer endpoint that you've set up, and you can see a list of the install errors that have happened and a count of the number of installations that have actually failed with that. You can restrict this down, so you can say, minimum count is 2. So you can filter out kind of one-off errors and things like that. But if you see errors that are coming in here regularly, you probably want to go in and add a resolution text. So you can click Edit. And then if I wanted to add new resolution text here, I just click the plus sign and can type in whatever the resolution text is. And once that is in the system, anytime an error or anytime another installation fails with that same generic error, that content will be presented to the user instead. So we've actually seen a huge drop-off in support requests to our user community and to our customer support when we can put the workaround kind of directly there for an end user. The other advantage is it doesn't leave an end user in kind of a partially installed state for as long, which can be bad. All right. Actually, I'm going to cancel that deployment so that we can go over and look at the contributor tool. So the last demo that I want to show is of the contributor tool. So we've got this code that we've shared out through GitHub. We put this installer out there on Heroku for people to be able to easily install it. And somebody comes to us and says, it's really great, but we really need a favorite color field on contact. So what you can do then is direct them out to the contributor tool in mrbelvedere. They go out, they start a new contribution, they grant OAuth access to their GitHub account and to a DE org. They create an issue title and description, which becomes an issue in GitHub. They give a name for the feature branch that their code's going to be done in. And then the contributor tool takes off and syncs everything, syncs up their org with GitHub. And then they go into their org, add a custom field, come back to the tool, commit that to GitHub through the web interface, and then submit a pull request to you so that you can get that contribution to your project. Now, all right. So the first thing that I'm going to do here is log out of admin so that I am just a regular user now. And I'm going to go to the contributor interface. And when I click here to start, the first thing it's going to do is ask me to grant access to public repositories. And then I want to go through and start a contribution. So I'm going to select the package that I want to contribute to. This is any package that has a current GitHub version configured on it is made available to contribute. And I'm going to go ahead and say I want to create a new issue in the repository and submit that. And then I'm going to give it a name, or kind of the end of the name for a feature branch that I want to have my work done in. I'm going to connect it to a DE org. I'll connect it to the same one that I used with the install earlier, so it's not giving me the grant screen anymore because I've already granted it access to this org. And then it's, like before, going to go through and inspect the org. And now it kicks off the synchronization process. So quick snapshot of what the synchronization does. It, on behalf of the user, creates a fork of your GitHub repository. It creates a feature branch inside of that repository for them with the name that they provided. It creates a GitHub issue with the title and description that they created from the contributor tool. Then it kicks off an installation process that runs the installer to install the head commit in their feature branch, in their fork, into their org. So it's essentially setting up a development environment. And then once the installation completes, the final step is it does a final sync. It retrieves everything back from the org and commits that to GitHub. So if the org made any kind of org-specific changes in the metadata, it captures those changes and makes sure that the branch is in sync with what's in the org. That allows us to be able to go and detect what's going on in the org later. Now, all right, cool. So those should be. Okay, so while that is running and deploying into the org, I am going to go ahead and go to the setup panel, and I'm going to add this new custom field. So we want to create favorite color on contact. We're going to make it a text field. Call it favorite color, 255 length. And save. Yeah, it's actually not. The deployment is pending. So I guess actually while that runs, if there's any questions in the audience while we're waiting on that to complete. Nobody? Okay. Yeah, so what a contribution will look like ultimately for a user. And of course, I don't have any in here. So the process for the contributor tool from here, once this sync runs and it gets basically GitHub and the organization completely synchronized, is then you go into the org, you add whatever metadata you want to add or modify whatever metadata is in the package. You go to setup, create packages, and go to the package that it deployed into the org for you. You go to add, and then you go to custom field, and you select and add basically that new custom field that you added to the package. When the contributor tool goes out to check your org to see if there's any uncommitted changes in your org, it's only retrieving the metadata that's in the package in the org. So you can create other custom fields, not add them to the package, and the contributor tool is not going to fetch those. It's only going to fetch the ones that you go in and explicitly add to the package. So you have to kind of explicitly add metadata. And yeah, it's just churning away on this last one. So when you go and check for changes, there's this Save Changes button up here. It's a little bit grayed out right now. All right, cool. It finished. So now it's actually doing the retrieve from the org. It created a new commit in the GitHub repository. So I can actually click here and go see that commit. And these are basically the changes that my org made in the retrieve versus what was deployed into the repo. So at this point, I'm all synced up. I want to go ahead and add this to the package. I want to come in and check for changes. And this is retrieving the package metadata from the org and then doing a comparison of all of that metadata versus what's in the GitHub repository right now. And it notices, hey, there's new unsaved changes, so I can go ahead and click Save Changes, added favorite color. Submit. Great. Well, yeah, so what that should do is go through and actually create a commit in the repository. And then I can use this submit for review. And this just prompts for different content that we want to kind of concatenate together in a pull request body so that we can get information from a contributor. What critical changes are you making to the application that we need to make sure and warn users about and such. And when I hit submit here, that would actually go through and create a pull request in GitHub. And that pull request would be from the feature branch in the fork repository into your main repository. So you have a contribution. You didn't do anything. You didn't really have to set up much infrastructure for the contributor, and your contributor didn't really have to know anything other than how to make the changes inside of Salesforce and how to create a GitHub account. So now, big safe harbor on this one. Mr. Belvedere is actually about to be completely revamped. My job for the last 3 years has been maintaining this kind of two separate suites of technology. One is Cumulus CI, which is largely built on Ant and the Force.com Ant migration tool. It uses the metadata API for almost everything, uses username and password for login, not OAuth. Mr. Belvedere, on the other hand, it uses a custom-written Python metadata API client, uses OAuth for access, and uses this like static map of metadata that's restricted only to the metadata API right now. Cumulus CI 2.0 is a project that's underway right now. It's rewriting Cumulus CI into pure Python and making it configurable through a single YAML file that is inside of the project repository. And it's basically a system to allow you to easily run predefined tasks and flows. Flows are just sequences of tasks. It's flexible and allows custom tasks to be plugged in. And it has access to multiple APIs of Salesforce and also to features and functionality of Salesforce DX. Mr. Belvedere 2.0 then becomes essentially the web interface on top of Cumulus CI. So Cumulus CI is a command line that developers can use to kind of quickly deploy and run all these different development tasks. Mr. Belvedere takes all of those tasks and flows and presents them as available to users through OAuth access and a web tool. It inspects the cumulus.ci.yaml file in order to look at the dependencies in the repository, presents any task or flow that's available to end users. And the key part is rather than Mr. Belvedere having its own code to do all its API interaction, it's offloading all the API interaction to Cumulus CI, which we're using for our builds every day, and we know is really stable. And finally, I'd love to see Mr. Belvedere kind of plug in as a Canvas app because it seems like a really natural thing to just have an upgrade your product tab or something along those lines. And one last note that I'll give about using Mr. Belvedere with Apex tests, when you deploy managed packages through Mr. Belvedere into an org, even a production org, no Apex tests are run. But every single step that does an unmanaged deployment into a production org is going to kick off every unmanaged test in that org and will fail even if that's the case. That can be a little bit confusing for customers. We actually provide, that's the most common failure that we have, and that was the reason that we actually wrote in the ability to present error resolution content to users, was we have a resolution content for that. And as far as next steps, you can go launch your own instance, Salesforce Foundation /Mr. Belvedere. Follow the README. It's pretty easy to get up and going. The other link here is for Cumulus CI. There's a branch feature 2.0, which is where all of the rewrite of that is going on. And I guess the last is a quick plug. We're actually hiring at Salesforce.org, bit.ly/SFDO dev. Cool. Thanks.